Example 27 is an interesting example in which we can consider a square ABCD, and in this square we know two of the vertices B and D to be the following two complex numbers. Now, what I want to do at the end of the day is to find the remaining two vertices A and C. So of course I'm going to begin by letting my four vertices represent four different complex numbers, and I bear in mind my aim is to solve for A and C at the end of the day. Then it will be helpful for me to draw a diagram as has been printed in the notes for you to illustrate the scenario. And I know that these four complex numbers will all be taken relative to the origin O. Let's say O is somewhere over here. Then what can I say about this line here? Well, it is going to be B minus A, and if you fall back to your vectors knowledge, you'll find that this is just the vector AB, which is going to be OB minus OA. And similarly, I can also find AD, DC, and CB, so on and so forth. However, in addition to that, I also know some other properties of a square. Namely, I know that this angle must be 90 degrees, which means that this line over here is simply a rotation of this line by 90 degrees in this direction, which is anti-clockwise. So I can see that this is going to be a 90 degrees anti-clockwise rotation, which I know is simply the same as multiplying the complex number z by I, okay, which is how I obtain this over here. So I know that AD will be I times of B minus A. And what have I done? I have written A, which is my unknown, in terms of D and B, which are two known complex numbers. And hence, I would be able to solve for my unknown complex number A simply by making A the subject and then rationalizing this later on. Hence, I am able to find that A is equals to 4 plus 6i. By this point, I believe you should be confident in working with complex numbers, so I'm not going to go through the details. Now let's move on to finding C. In fact, we can see that it can be done in the same way, and I know that DC is going to be equal to AB. Taking note of the direction, I have to go in the same direction, which means that B minus A is C minus D. And so once again, I have written my unknown C in terms of my three known complex numbers A, B, and D, and thus I am able to work out the two complex numbers A and C. Now what happens if I had drawn my diagram differently? Well, if instead of drawing this way, I had drawn it like that. A square with my four vertices A, B, C, and D. Well, not to worry, I will still get the same two values as my other two vertices, but now, because of the different ordering of the vertices, the two values will just be swapped. Okay, my A would now be the original value of C, while my C will now be the original value of A, but what I get would still be the same answer.